Welcome back to the new video. In this video, we are going to see what are elementary signals. In the previous video, I explained you first classification of signals. Signals are of three types: analog, discrete and digital. And I summarized that there are basic two categories of signals. One is called CT signal, which is continuous in-time signal, and the other one is called DT signal, discrete in-time signal. For example, if I take a sine wave, this is a continuous in-time signal. On x-axis we have time and on y-axis we have amplitude. If I have to draw a discrete part of the signal, it looks like this. It is not continuous in time, but it is discrete in time. The samples are at regular intervals of time. Something like this. So here we will use the notation n, which is again independent variable time, and this is again amplitude. Here we will use the notation x of t is equal to sine t, the name of the curve, and here we will write x of n is equal to sine n. So this is a continuous in-time signal and this is a discrete in-time signal. So this we have seen in the previous video also. Now coming back to the today's topic, this video's topic, we are going to discuss about elementary signals. There are elementary signals like the first one, even this also we have seen in the previous video, but let us discuss in detail. The first one in the elementary signals category is unit step signal. This is also called as unit step function. So in this subject from here onwards, wherever I use the name signal, it is also holds good for the term function. A function is also called as a signal. If we look at the basics part, like which we have learned in our non-engineering subjects, during the 10 or CBSE, that is 11 and 12 or intermediate, we have seen this part as a wave, sine wave, cos wave, like that. So the three terms, signal, function and wave, all are same. So I can write sine wave, signal or sine signal or sine function. So I hope I am clear. So unit step signal or unit step function is the first one in the category of elementary signals which we are going to learn. The definition of this signal is a signal whose amplitude remains zero. This is a graph on, we already know, on x-axis we have time and y-axis we have amplitude. A signal whose amplitude remains zero, amplitude is zero here, a signal whose amplitude remains zero for all negative values of independent variable. This is 0 and these are all the negative values of independent variable and these are all the positive values of independent variable. A signal whose amplitude remains 0 for all the negative values of independent variable and it remains 1 for all the positive values of independent variable is called as unit step. The notation for this unit step is u of t. It is u of t. So u of t from here onwards is called unit step. You write like this, u of t. It is a signal in such a way that its amplitude remains 0 for all negative values of independent variable and it remains 1 or it is 1 for all the positive values of independent variable. So I gave you just now two representations. One is the definition of a signal, the statement which I told, and this is the graphical representation. Coming to the third one, mathematical representation. we will write like this: u of t is equal to 0 for, this notation is called as for, u of t equal to 0 for t less than 0, and u of t is equal to 1 for t greater than or equal to 0. So this is called mathematical representation of the signal unit step. Now coming to the unit step sequence, I just now explained you there are two types of signal categories: continuous in time, discrete in time. Continuous in time is notated by x of t, and discrete in time notation is x of n. So similarly here we have discrete unit step also, that we will call it as discrete sequence. We will use n as independent variable, which is time, and this is amplitude. Notation is u of n. Amplitude remains 0 for all negative values of independent variable, and from 0 onwards its amplitude is 1. These are regular intervals of time. The space between each sample is unique. So this is called unit step sequence. So this is the representation for unit step signal, and this is the graphical representation for unit step sequence. So that is about the first category of signal element in the category base elementary signals. So first elementary signal which we are learned is unit step. Now coming to the second one, unit impulse. Let me draw the graph for the unit impulse t, and the notation for unit impulse is del of t. This is also called as delta function. Unit impulse is also called as delta function. The graph looks like this. This is the graphical representation of a unit impulse or delta function, and definition is the area under the curve. The area under the curve approaches 1 if width approaches 0. Say for example, take a curve like this. This is a curve. If I want to find out the area under this curve, this will be the complete area under the curve from here to here. So this area under the curve is approaching 1 as the width approaches 0. Width is, say for example, from minus 7 to 7. It is approaching 0, minus 6 plus 6, minus 4 plus 4 like that. So as the width is approaching 0, the area under the curve is approaching 1. So such a signal or such a function is called as delta function, unit impulse function, unit impulse signal. And coming to its discrete version, in the discrete version it is n, del of n, and it will be having only one sample at origin. So this discrete version of unit impulse is also called as unit sample, because there is only one sample. So for this signal, if you observe, for all negative values of time, amplitude is 0. For all positive values of time, amplitude is 0. But only at origin, amplitude is 1. But this is a unit impulse signal, but whereas this is a unit impulse sequence, it is having only one sample at origin. And coming to the mathematical representation, del of t is equal to 1 for t equal to 0. For this category I am writing is equal to 0 else, elsewhere. Similarly for this, del of n is equal to 1 when n equal to 0, and del of n equal to 0 elsewhere. So like that, we have another elementary signal, unit impulse. The area under the curve approaches 1 when the width approaches 0. Such a function is called as unit impulse function. Other name is delta function. And the discrete version is called as unit sample. The amplitude of a signal is 1 only at origin and it is 0 at elsewhere. Such a signal is called such a sequence is called as unit sample or unit impulse sequence, or also called as delta function. Let us see one more in this category.